Okay, everybody, this is Mr. Bells, and I'm going to run you through section 7.3. And 7.3 maybe is going to be one of the most difficult ones. So I'm going to be patient with it, you be patient with it, and let's see how we can do it. So the first thing I need to do is I need to give you a general background on some stuff. So I'm just going to make up a crazy equation right now. 3x plus 2y equals, no, let's put an extra one on here, plus 4z equals 8, and 2x minus 3y plus z equals negative 5, and 3x plus 4y plus z equals 11. And technically, if I have three variables, I think we've talked about this before, two variables would make a line on a coordinate axis system, three variables would make a plane. So it could be that these three planes intersect in, like, say, the corner of a room. Right up there. So like that corner right up there could be three planes intersecting. However, it's possible that the three planes could be in a situation where two of the planes are parallel, like the ceiling and the floor, and one of them's the wall. And then there's no solution whatsoever. And it could be that all three planes intersect. Like, let's say we have the plane of the wall and the plane of the ceiling, and then we got another plane that's kind of going diagonally through it. And what they end up doing is not intersecting at a point, because remember, they go on forever, but that would be an entire line that would go through, and they'd have infinitely many solutions. So just like two variable systems, three variable systems, or more, could have infinite solutions or no solution, or exactly one solution, like I showed you for the corner of the room. Okay, so what we're going to get to today is something called REF, which I know you guys have seen on your calculator, and RREF, and we're going to do all this stuff by hand today. So we're going to try and solve these systems this way. So the first thing, and ignore this problem anymore, just know that it exists. What does an REF look like? Well, an REF looks like this: 1 0 0 1 0 1. It looks like these three locations, and then there'll be other numbers in here. Let's say this is 2, this is negative 3, this is 4, and then over here maybe you got a 3, a 5, and a 2. Okay, so this is what an REF looks like. It stands for reduced, or excuse me, row echelon form. Row echelon form. And it almost looks like on this diagonal you have the identity matrix right there, except we don't have the zeros in these spots. That's what RREF stands for. So before I go to RREF, I want to show you what this one is, or how this works. So if we can get a system of equations like this into row echelon form like this, then I can go ahead and solve it. So you'll notice here, if this represented x, this represented y, this represented z, you can see that z equals 2. So I can go ahead and I can put in that my third variable is 2. Now if my third variable is 2, the z is equal to 2, then I could substitute that 2 right up into that spot. Well, that equation technically says 0 x's plus 1 y plus 4 z's equals 5. Okay, so, well, what is z? Z is 2, so I plug that in there. 4 times 2 is 8. And now I got y plus 8 equals 5. I subtract the 8, and I get y equals negative 3. And I can plug that right in there like that. So now I got those two. So now that I have my y value, negative 3, and my z value, 2, I can plug those into here. So negative 3 goes into the y, 2 goes into there, and technically this top equation will be x, right? Single x. And then when I substitute that in, that'll be minus 6. 2 times negative 3 is also minus 6, equals 3. So now I have x minus 6, and minus 6 is minus 12. So now I've got x minus 12 equals 3. Add the 12 to the other side, and I get 15. And this 15, negative 3, 2 is the solution to this system. Again, this up here was just made up so you know. But if I had a system like this that I could reduce to this form, I'll put in row echelon form, then its solutions would be 15, negative 3, 2. So what does an RREF look like? Well, an RREF would look like this. It would actually give you the identity matrix instead of having to do this back substitution like we did on this one. 0, 1, 0, negative 3, and 0, 0, 1, and 2. So when we're done on an RREF, it would give it to you just like this by hand. And you know that. We've done that on our calculators. That's what the RREF actually gives us. So what I'm going to try and do now is I'm going to try and show you how to do all the little computations in this stuff actually by hand to get to this and then this. And I'm going to go slowly, but remember there's Educreations videos up there too that can help you out with it. Okay. So here we go. So section 7.3. So one of the first things we're going to do is we're going to talk about notation. So how do I manipulate one row to another row? And when I have a series of numbers like this, there's a bunch of different rules that I can do. Like I could take this entire row right here, row 1 and row 2, and I can add them together, right? And that will be a true equation. I could multiply this top row by any number and add it to another row. I could take any row that I want and divide it by any number. I can add rows 1 and 3, or rows 2 and 3, or rows 3 and 1, or any of those possibilities I can do. I don't like to do this, but I could even swap out and take row 3 and put it up at the top, or row 1 and put it down at the bottom. The order in which they occur, top, middle, bottom, doesn't matter. The other thing I could do is, right now, if this is x's, y's, and z's, I could put my z's first if I wanted to. I just got to remember that in the end when I find my solutions. Okay? So what I'm going to try and do is, we're going to try and get this first in ref form. So ref form, again, looks like this. 1 in the top left column, followed by 0 and 0. And then a 1 in the middle of the second row, and then a 0 below it, and then a 1 in the last one. And I'm going to start and I'm going to work this way, just like this. I'm going to get 1, 0, 0 in these things by combinations of different lines. Okay? And we're going to look at notation because that's what some of the homework's going to ask for too. So the first thing I'm going to do is I'm going to say, hey, I've already got a 1 here in this one. So let's just go ahead and copy that down. So 1, negative 1, 2, and 7, just like that. Is that good? Then I'm going to say, hey, in order to kill off this 5 right here, because remember I want it to be a 0, what would I have to multiply this row by to add to this row to kill off that 5? Well, if you said 5, if I multiply this by 5, 1 times 5 is 5, and if I add 5 and 5, I actually get 10. So I need it to be a negative 5. So I'm going to do negative 5 times row 1, and that's what my little notation looks like. Bring that in a little tighter for you. Negative 5 times row 1. And I'm going to add it to row 2. And I'm going to put those numbers right here. Okay? So negative 5 times 1 is negative 5, plus 5 is 0. Now I've got my 0 there. Negative 5 times negative 1 is 5. And plus this minus 2 is a 3. And negative 5 times this 2 is negative 10. Plus this 4 is a negative 6. And negative 5 times this 7 is negative 35, plus this 20 is negative 15. I'm like, yeah, I did that. Look at that. So now I need to get a 0 and the 1 below that. So I'm still going to use my top row, and now I need to multiply it by something to kill off a negative 3. So hopefully you can process that I'm going to do 3 times row 1 this time. I'm going to use row 1 again, because that's where my 1 is, and that's what I can use to kill off stuff. So 3 times row 1 plus row 3. And let's get the new things down here. So 3 times 1 is 3, minus 3 is 0. 3 times negative 1 is negative 3, and negative 2 is negative 5. And 3 times 2 is 6, and 5 is 11. And 3 times 7 is 21, and 5 is 26. We're like, ooh, that looks kind of scary right now. I got a 1, negative 1, 2, and a 7, a 0, 3, negative 6, negative 15, 0, negative 5, 11, and 26. Okay, so here we go. Let's see if this follows along. So I got 1, 0, 0. Now I need to get this to be a 1. Now, one of the things that I can do is I could just, oh, look at, that's divisible by 3, and that's divisible by 3. I'm just going to divide my entire second line by 3. So let's go ahead and recopy the top line in. 1, negative 1, 2, and 7. And now I'm going to do 1/3 of row 2. So divide everything in row 2 by 1, or by 3. Then we get 0, I'm going to get 1, I'm going to get negative 2, and I'm going to get negative 5. Everybody good with that? I divided everything through there because I needed that to be a 1. And now I'm going to, just for the sake of this, I'm just going to recopy row 3 here because I don't want to do too much stuff. In class, it's a little bit easier. I can refer back to things and talk about things in different ways than I can when you don't get to ask me live questions. So just going to recopy that in 0, 0, negative 5, 11, and 26. Okay, so again, now I've got 1, 0, 0. I've got a 1 in the second one. Now I need to get a 0 here, right? Because that's what R, E, F, right? R, E, F looks like. Okay. So close. So now I'm going to say this. I'm going to kind of swing like this and start going backwards here. I'm going to recopy number 1. My bad. Recopy line number 1, 1, negative 1, 2, and 7. I'm going to recopy line number 2, 0, 1, negative 2, and 5, because those are perfect so far, right? They got the 1, the 0, and the 1 in them. And now I need to get rid of this 5 right here. So what do I multiply row 2 by? So yeah, I'm done using row 1. Now I'm going to use this 1 right here, use this 1 here to kill off that negative 5. So I'm going to have to multiply 5 times row 2 and add it to row 3. So this is going to be a 5 row 2 plus row 3 using these 2 rows right here. Okay? So 5 times 0 is of course 0, plus 0 is 0. Like, yeah, I didn't lose that 0. 5 times 1 is 5, plus negative 5 is 0. 5 times negative 2 is negative 10, plus 11 is 1. And 5 times negative 5 is negative 25, plus 26 is 1. Look at that. So I kind of got 2 birds with 1 stone, or so they say, right? So now I've got 1, 0, 0, I've got 1, 0, and I got a 1. And you guys can already tell that this thing right here is going to look like this. I'm going to try and do the solution right over here without messing up my stuff going towards the thing here. So according to this, if I did my back substitution, z is equal to 1, right? I plug 1 into here. Negative 2 times 1 is negative 2. And if I add that to the other side, right, I move that negative 2 to the other side by making it positive 2. That would give me 7. And then I put a 7 into here and a 1 into here. And that's negative 7 plus 2. That's a negative 5, right? Negative 7 plus 2 is negative 5. So I add 5 to the other side and I get 12. So according to this, my back substitution should be 12, 7, 1. 12, 7, 1. Okay, so I'm going to take a tiny little break right now just so you can see this. And because if this didn't work out, we're pretty much screwed. So I'm going to go back to my original matrices right here, and I'm going to put it into my handy dandy calculator and see if this works out for us. So hopefully it'll be good. So second matrix, and I'm going to go to edit, enter, and I'm going to make this a, you'll see this here, I'm going to make this a 3 by 4, 3 by 4, and I'm going to put all of those numbers in. So that's a little clearer for you now, right? So 1, enter, negative 1, enter, 2, enter, 7, enter, 5, enter, negative 2, enter, 4, enter, 20, enter, negative 3, enter, negative 2, enter, 5, enter, 5, enter, just like that. So I got them all in. And then I'm going to do second quit. So So I have a clear screen here. I'm going to do second matrix. I'm going to go over to math. I'm going to go to reduced row echelon form, the RREF, which we're going to do by hand. We're going to finish it off by hand in just a second. I'm going to hit enter. I'm going to do second matrix. I'm going to pull up A, the one that we just put in there. I'm going to hit enter, and it shows the solution is 2, -3, and 1. Right. So where did we go off on our problem? So let's double check this again. And oh, yep. Some of you were probably yelling at me in the problem when I did this, right? This was a -5 right there. I forgot to copy that. -5 down when I brought it down. So that's a negative. And see, that's why we check. That's our DIMS thing. So if that's a -5, when I plug the 1 into here and I move that over there, that gives me actually -3. That's actually going to be an easy fix right now. Is everybody good with that? So when I plug the 1 back in, -2. Move that over to the other side, that's +2. 2 and -5 is -3. So now I'm plugging a -3 into here and a 1 into here. And -3 times -1 is 3. 1 and 2 is 2, so that's 5. When I subtract 5 from the other side, 7 minus 5 is 2. So 2, -3, 1. That's the solution. And surprise, surprise, 2, -3, 1. That one works right there. And yes, there's a lot of ways that you can mess these things up. We're just going to do our best to not have those things. Okay, so now I've got this with our little fix, making sure I copy down every single sign, that negative sign. And now I'm going to try and get this to be a 0, this to be a 0, and this to be a 0. So I'm going to work my way back, and I'm going to see if I can get my RREF form to look just like that. Okay? I can even scratch this off. So 2, -3, +1. Good? Okay, so here we go. So the next thing I'm going to do is I'm going to use, you know how I use this row to kill this, and then this to kill this, and then I got here? Well, now I'm going to use row 3 to kill the thing right above it. So I'm going to try and get rid of this -2. And you want to do this pattern every single time. So we're going to use row 3 because that's not going to mess up anything in these locations because those are both zeros. So let's do my next one. So 0, 0, 1, 1. And now I'm going to kill off this this little -2 right here. So I'm going to do 2 row 2 plus, 2 row 3 plus row 2. 2 row 3. So what is 2 times 0? 0 plus 0, still 0. Doesn't mess that up. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus -2 is 0, and I got my 0 in that location. 2 times 1 is 2 plus -5 is -3, and look at that, that's the -3 we wanted from before, which we have. Yay. Okay, so now that I've done that, now I'm going to use this one right here to kill off that 2. So on this one right here. So now I'm going to do -2 row 3 plus row 1. And again, this is a notation you're going to see in the online homework and stuff for some of these things. So -2 times 0 plus 1 is 1. -2 times 0 plus -1 is -1. -2 times 1 is -2 plus 2 is 0. And -2 times 1 is -2 plus 7 is 5. So now I got that. And you're like, well, that's not the 2 that I wanted to have. And that's fine because this thing's not my 0 yet. It's almost in RREF form, but I got to get that to be a 0. So final one right here. I'm going to keep in my bottom row the same, and I'm always going to keep my bottom row the same once I have it that way. My middle row is perfect. I don't want to change that. Middle row stays the same, just the way it is. But now I'm going to use my middle row to kill off this -1. And I hope you can see that all I have to do is add row 2 plus row 1 because they're already opposites. But if I had to do something else, some more math, some crazier stuff, I could do that. Okay, so let's add them together. So 0 and 1 is 1. 1 and negative 1 is 0. 0 and 0 is 0. And 5 and negative 3 is 2. And look at that. 2. X, no y's and no z's equals 2. No x's, 1y, no z's equals negative 3. And no x's, no y's, and 1z equals 1. And you can see that that works. Cool. And if you really wanted to go back crazy, because I want to make sure you make the connections between these things. So one more time. This was my original problem. And technically this is saying x minus y plus 2z equals 7, and 5x minus 2y plus 4z equals 20. Negative 3x minus 2y plus 5z equals 5. Okay? If I plug 2, negative 3, 1 into this matrix up here, it should equal 7 when I plug it into line 1. It should equal 20 when I plug it into line 2, and it should equal 5 when I plug it into line 3. And if I got this, a 2, a negative 3, and a 1, that means that it must be just like what we did earlier, and we said, hey, that actually was an actual corner. The intersection between those three planes is that location right there. Okay? Okay, so I know that was a lot. And again, we'd take 2 or 3 days to practice some of these things, to do it, and it would still be challenging for some, but I think it's good mind exercise for you. So what happens when we get problems that I said before, that maybe you have infinite solutions, or maybe you have no solutions? What happens there with these larger systems? So I'm going to try and do one of those right now. So here's an infinite solutions problem. Look at that. I'm telling you beforehand what it looks like. You guys know from the calculator what it looks like, right? So let's see if we can figure this out. And then once we know that it has infinite solutions, can we actually describe what those infinite solutions are? Okay, so right now I've got, this means x plus y plus z equals 3, right? And 2x plus 1y plus 4z equals 8, and 1x plus 2y minus 1z equals 1. Okay, so let's try and put it in REF form and see what happens from there. So here we go. I like my 1 up here. I'm going to go ahead and keep that. I'm going to keep row 1 the same. And then I'm going to do negative 2 row 1 plus row 2. Negative 2 times this plus this one. So negative 2 times 1 is negative 2 plus 2 is 0. And negative 2 and 1 is negative 1. And negative 2 and 4 is 2. And this one right here, right? Negative 6 and 8 is also 2. Good. So now on the last one, I'm going to do negative row 1 plus row 3. I'm just going to do the opposite of this row, and I'm going to add it to the bottom row. So negative 1 plus 1 is 0. Negative 1, right? Plus 2 is 1. And negative 1 minus 1 is negative 2. And negative 3 plus 1 is negative 2. And now I got my 0, 0 here. That looks pretty good. I want a 1 in this column, right? That's my next thing. So recopy down my top line. So I got a 1, a 1, a 1, and a 3. And then how can I get this to become a positive 1? Well, I'm hoping you just realize that I changed the sign. And I can't change the sign on one number, but I can change the sign on everything in my line. So that would become 0, 1, 2, and 2. And then, oops, sorry, negative 2 and negative 2. So I changed all their signs. And then at the bottom row I have, and I think you guys just saw what just happened, right? I also have 0, 1, negative 2, and negative 2. And I think, conceptually, hopefully you can see this, as that these end up being the exact same planes, which means I have an infinite solutions possibility because 2 of the planes overlap. It's like wall, same wall, and ceiling are all going to intersect. But let's go ahead and do it out the final way. So I need to get this to become a 0. That's my next step in getting REF. So my top line's good, right? In fact, I'm going to do it a little bit bigger here. So 1, 1, 1, and 3 is good. 0, 1, negative 2, and negative 2 is good. And now I'm going to do negative R2 plus R3. So negative R2 plus R3, like that. And you'll see that I'm going to get 0, 0, 0, 0. And that, 0, 0, 0, right? No x's plus no y's plus no z's equals nothing. That's a true statement, right? And if that's a true statement, that means we have infinite solutions. And just like a long time ago, right? We said we get an answer that was the square root of negative 5. We just said, hey, that's no solution. And then later on in math, we came through and we said, well, wait, no, really, we're going to call that I square roots of 5. We're going to talk about all these imaginary numbers. So at certain points in math, we stop just because we don't want the brain to have to think too much at that time, and we'll pull it up later on in it. Well, now we're actually going to do that. So instead of just saying, hey, there's infinite solutions, we're going to list them all. We're going to write them all. And you're like, what the heck? How do you write an infinite number of solutions? Well, it actually is pretty easy. It just means we have to do it with letters or things that can represent anything with variables, right? So if I know this last thing is true, then x plus y plus z equals nothing. I can let z, my last variable here, z, equal z. And then I can define x and y based on that z. Okay? So like, basically I could have you all in the classroom pick any number that you wanted from negative infinity to infinity, and you could let that be z, and then you just have to back substitute it into the other equations to find out what your y would be based on your z, and your x would be based on your y and your z. Does that make sense? I'm open. Here we go. So I'm going to plug it into this next line right here. So this next line would be 0x's plus 1y minus 2z. And remember, z is z, right? Equals negative 2. So now I'm going to solve for y because I'm trying to get the y, the missing one right here. So what do? I move this 2z over, and I get y equals 2z minus 2. And that is what y is. So now I have that expression, 2z minus 2. I'm hoping that clicked for you. Okay, so now I can go to this top line right here, this top line here, and I'm going to substitute them all in, and I'm going to do this. I'll put a little green in here. So y is 2z minus 2, right there, right? And z is z, and it still equals that 3. Okay, so 2z and z is 3z, right? So that's 3z minus 2, and I have to move that to the other side of the equal sign. So that's going to be a negative 3z plus 2. So now I have negative 3z plus 5, negative 3z plus 5. Okay, so that's it. That is my infinite solution. So what is x? X is negative 3z plus 5. What is y? Y is 2z minus 2. And what is z? Z is any number that you want. And right now you're thinking, Mr. Bells, that just looks stupid. That's okay. This is going to freak you out a little bit. Here's my original problem. We're going to try this. So what I want you to do is just pick a number. You can do it on your own. I'm gonna do it here, and you can use the same one, or you can pick your own. So I'm going to say that my solution is going to have z before. So that means a solution to this system right up here is going to have that 4 in there. So I'm going to plug it into here. 2 times 4 is 8. 8 minus 2 is 6. And then negative 3 times 4 is negative 12. Negative 12 plus 5 is negative 7. And I'm going to say that negative 764 is a solution. Check mark, yay! I'm going to say that that works. Which means if I plug negative 7, 6, and 4 up here into this original equation, system set, it should work. But it's not just 4, it's anything. So you picked, I don't know, maybe you picked negative 2. So I'm going to have you pick negative 2. So z is negative 2. So now I plug negative 2. Negative 2 times or 2 times negative 2 is negative 4, minus 2 is negative 6, and then negative 2 times negative 3 is 6, 6 plus 5 is 11. I'm going to say that that also works. 11, negative 6, negative 2 also works. And if you come back up here, we'll just try a couple of these ones and see if that makes sense. Because if it doesn't, we're screwed again. So let's try negative 7, 6, and 4. So this says 1x, 1y, and 1z equals 3. So let's try it. 6 and 4 is 10. 10 minus 7 is 3. It does equal 3. Whoa. Let's try it for this one. 11 minus 8. That does equal 3. So they both work for line number 1. Do they work for line number 2? This says doubling the x. So that's negative 14. Right? And 6. Negative 14 and 6 is negative 8. And then 4 times 4 is 16. Negative 8 and 16 is positive 8. Oh, it worked for that one. Let's try this one. So 22. Ooh, this could be scary. 22 minus 6 is 16. And then 16 minus 8 is 8. It did work. So look at that. We will get infinite number of solutions. Again, if I go back to my calculator right here, I'll do this pretty quick on it because I don't want to take too much more time on this video. Go back to my calculator right here. I'm going to go second matrix. I'm going to go over to edit. I'm going to hit enter. It's still 3 by 4. I'm going to put in these ones. So 1, enter, 1, enter, 1, enter, 1. Oop, nope, 3. Enter. 2, enter, 1, enter, 4, enter, 8, enter, 1, enter, 2, enter, negative 1, enter, 1, enter. And then second matrix, and home screen, and second matrix, middle column math. I'm going to do an RREF for that matrix A. And you can see bottom line 0, 0, 0, 0, 1, negative 2, negative 2, and 1, 0, 3, 5. The exact same thing that I got, or some of the same things that I got. It did a little bit further than what we did. It tried to go reduced row echelon form as far as you can get it on that one. But it would work out to get you the same stuff. So hopefully that's good. Final thing that's going to be pretty quick. This is just to show you on a 2x2 how this would work. If this is a matrix equation, I could write an augmented matrix or coefficient matrix I've used before. 2, 3, 7, negative 1, 2, and 0. That's what it looks like. Where technically these are the x's, these are the y's, and these are the numbers. Okay? So that's how these whole things grow from this. A lot of stuff in there. Again, if you guys ever have any questions, feel free to give me a call and let me know. 720-9625. I have a Zoom meeting right now, so I got to get off of this one. See you guys.